What is up, Algebra 2 students? This is lesson 77. Our objective is how do you solve advanced radical problems? So we've been working with some radical problems earlier that were like the square root of n is equal to 4. So you would square both sides and you'd get n is equal to 16. So now we're going to do something a little bit more advanced on these. Instead of it equaling a number on the right hand side, it's going to equal a variable. Notice that. But still the same process of solving these. We want to get rid of the radical, so we're going to isolate that or get it by itself, and then I'm going to square both sides. So now I'm going to have n squared is equal to 6 minus n. So to solve this quadratic, I want to get everything to one side, so I'm going to add n, subtract 6. I'm going to get n squared plus n minus 6 is equal to 0. Let's see if this thing will factor. So I'm going to have n and n. Factors of 6, so subtract to give me 1. So it's going to be plus 3 minus 2, which means then that n plus 3 is equal to 0, or n minus 2 is equal to 0, which means n is equal to negative 3, or n is equal to 2. It seems like I went through that really fast. It's because we've already gone over how to solve things like this. So I'm assuming that you already know how. Feel free to watch it again or to go back and find that lesson on solving quadratics by factoring. And feel free to relearn that if you need to do so. So right now I have two answers. But since we squared both sides of this like this, we have to check for extraneous solutions. Look at that, it even told us to do so. Extraneous means extra. Sometimes whenever you square equations, you end up with extra solutions. So we're just going to check this. We're going to say, is negative 3, I'm taking this and plugging it in here. Is negative 3, is that really equal to the square root of 6 minus a negative 3? So is negative 3 really equal to the square root of 6 plus 3, or the square root of 9? So is negative 3 really equal to 3? Well, no, that's not true, because negative 3 does not equal to 3. I wish it did, because then if I owed someone $3, it would be the same thing as having $3. So this one does not work. That's not an answer. Let's check the other one. Is 2 equal to the square root of 6 minus 2? Is 2 equal to the square root of 4? Is 2 equal to 2? Well, yes. Turns out that it is. So this is my only answer here, is n is equal to 2. This one is what we call an extraneous solution, a solution that we found, but doesn't actually make this thing true. Number 8 is pretty similar to number 2, except notice it has this extra letter here. This one just has a radical equals a variable, and I think you have 4 or 6 of them like that. This one, notice it's a variable equals a number plus a radical. So the first thing we want to do is we want to try to get that radical completely by itself. So I'm going to need to subtract 2 from both sides. So I'm going to have k minus 2 is equal to the square root of 5k minus 14. Now we'll square both sides. The right hand side just becomes 5k minus 4. The left hand side, if we do a little thought bubble over here, is going to be k minus 2 times k minus 2. This is where we FOIL. K times k is k squared, minus 2k minus another 2k is minus 4k, and then plus 4. So left hand side comes out to be k squared minus 4k plus 4. So I'm going to go ahead and bring everything over to one side. Subtracting 5k and adding 14. I'll end up with k squared minus 9k plus 18 is equal to 0. Coming up here so I have more room, this is going to factor into k and k, 3 and 6, both of these negative, is equal to 0. So that means either k minus 3 is equal to 0, or k minus 6 is equal to 0. So that means either k is equal to 3, or k is equal to 6. Now we just need to check to see if these two are actually solutions. So let's see if that works. Is 3, is that equal to 2 plus the square root of 5 times 3 minus 14? Well, 5 times 3 is 15, minus 14 is 1. The square root of 1 is 1. So is 3 equal to 2 plus 1? Yes, that one checks out. So this is one solution. Let's check the other one here. Is 6 equal to 2 plus the square root of 5 times 6 minus 14? 5 times 6 is 30, minus 14 is 16. Square root of 16 is 4, so is 6 equal to 2 plus 4? Well, yes, that one does too. So that is an answer as well. So my answers, I would put in a fancy one like this, 3, 6. That's my solution set. Normally just list those from smallest to largest. Alright. So this one here is kind of like number 8, the one we just did, except for it's already kind of sorted out. So I need to square both sides. So on the right hand side I'm going to end up with 34 minus 5b. Left hand side I'm going to end up with b squared minus 16b plus 64. Because that's because I foiled it. B minus 8 times b minus 8 and FOIL. Bring everything to one side. I'm going to add 5b. Subtract 34. So it's getting kind of messy. I'll try to clean this up a little bit. B squared minus 11b is equal to, oh sorry, not equal to, plus 30 is equal to 0. So I'm going to find factors of 30 that add up to 11. And I believe that would be 5 and 6, because 5 times 6 gives you 30, and 5 plus 6 gives you 11. So that means b minus 5 is equal to 0, or b minus 6 is equal to 0. That means b is equal to 5, or b is equal to 6, based on what we found. So let's check those. Is 5 minus 8, is that equal to the square root of 34 minus 5 times 5? Oh, that's really horrible, 5. So is negative 3 equal to 34 minus 25? So equal to the square root of 9. Well, is negative 3 equal to 3? No, those don't equal, so this one is not a solution. Let's try the other one. Is 6 minus 8. Is that equal to square root of 34 minus 5 times 6? 6 minus 8 is going to be negative 2. Is that equal to 34 minus 30? So really it'd just be the square root of 4. So is negative 2 equal to 2? No, those are not equal. So that means that one's not a solution. Well, notice neither one of them came out to be a solution, so then I would say no solutions. And you might have a couple more on your homework that's the same way. Alright, so we have one more problem type. And this is where, notice we have two radicals, one on either side, but then there's also another number. See that right here? So we're going to do the same thing we have been doing, and that's just squaring both sides. But this one's going to get a little bit more messy. On the left-hand side comes out to be pretty nice, of just negative 4 minus 4k. But the right-hand side, we kind of have to FOIL. And so it's going to be negative 1 plus the square root of negative 5 minus 6k. So first would be negative 1 times negative 1. It's going to be positive 1. Outer is going to be negative 1 times this, and inner is going to be negative 1 times that. So it's going to be minus 2 square roots of negative 5 minus 6k. And then the last is going to just come out to be negative 5 minus 6k, because it's going to be like the square root squared, which gives you the square root. Now let's try to get everything without square roots on one side, everything with on the other side. So let's see here, I'm going to subtract 1 and add 5. Subtract 1, add 5. That's going to be negative 5 plus 5, so that all goes to 0. And then I'm going to add 6k. So then this is going to come out to be 2k is equal to negative 2 times the square root there. And then I'm going to divide by that negative 2. Now I end up with k is equal to the square root of negative 5 minus 6k. And now to the point, kind of like we started off on the first one of these lessons, I just need to square both sides. So I end up with k squared is equal to negative 5 minus 6k. Coming over here to where there's more room. I'm going to add 6k and 5, so I'm going to have k squared plus 6k plus 5 is equal to 0. Factoring that, I'm going to have k plus 5, k plus 1. It's going to give me two solutions of k is equal to negative 5, or k is equal to negative 1. You can go through the process. I'm just trying to save a little bit of time. Then we need to check those. Yes, it turns out they both come out to be true. So then my solution set is going to be negative 5, negative 1. Alright, so your homework is going to be a worksheet. Make sure you pick that up and ask questions on any of those, like here on number 13 that have this a little bit more complicated one as you need them. Good luck, guys.